Interesting. So an area where we can maybe at least find some progress or maybe more emphasis on that area. So I want to start from the top with you, and I mean literally the top, the brain. So the act of thinking, right? There's this idea that's been enormously popular in the West, namely that everything that we are is inside the brain, that the act of thinking is, the only source of the self, the source of our identity, all of our thoughts. It all happens up here. In your TED talk, you take a brain. I don't know if that probably wasn't a real brain, just a mock-up, and you said, "Here you are," right? Like this is all of you, and it is like philosophically, this is the famous Descartes dictum, right? I think, therefore I am. But there's another way to look at cognition that's at the root of a lot of your work, namely that we are and have always been brains in a body. And so you've
Right.
opened up my mind to the view, I think you expressed it this way once, that brains didn't evolve just for thinking, but they evolved to optimize the movement of the organism in the outside world. Can you
Right.
talk to us a little bit about how you conceive of the brain and our thoughts on one hand being connected to the body and this notion of embodied cognition?
Yeah. So I would change Descartes' dictum not to "I think, therefore I am," but "I move, therefore I am." And I think that's a little bit more relevant. And it's interesting too, because embodied cognition is not just neuroscience meaning in the brain, but embodied cognition is an overlapping interdisciplinary field of research that involves cognitive science, culture, anthropology, philosophy, especially, and neuroscience and computer science and things like that. But I think it's overwhelmingly clear now that brains evolved from movement first, and out of that came mental states. One of the first people to think about this was Rudolfo Linas, who wrote a book called Eye of the Vortex, From Neurons to Self. And the idea there is that he really was one of the first to sort of theorize about this, that brains are prediction engines. The brains evolve from movement, right? If there's no brain, if there's no central nervous system, there's no movement. But when you move, you have to make predictions about your environment, what's going to be around that bush, your way your body's moving in relation to the environment. And so you need to start making predictions about things. And so that's from an evolutionary perspective. And so now we know that the brains really are these at the heart of how brains work is this sense of prediction. It's about predicting what was going to be the outcome of your body's movement on the world, on the environment, and how the environment's going to respond, and then what you need to do to optimize that for survival. That's an evolutionary perspective. Now we think of embodied cognition as really, it's just that embodied cognition and embodied consciousness is really the view that the body plays a central role in shaping cognitive processes, and even maybe the nature of consciousness itself. The body and how it moves in the world and how it interacts with the environment, and the fact that it's coupled to the environment. When I say cognition and cognitive processes, I mean thinking, like you said, decision-making, perception, attention, emotional regulation, like those kinds of things. I refer to as cognition or cognitive processes. So that's the view there, that consciousness does not really, it's not only in our head. We have to think about consciousness not as something that's up in our heads with, and there's a neural brain activity that you can say correlates with the experience of consciousness or consciousness as experience. No, we think that consciousness is something that we do, we enact, or that we embody. And so this idea of this perception action cycle. In fact, J.J. Gibson said, I put this in my TED Talk too, in order to perceive, we must move. But in order to move, we also must perceive.
So do you subscribe to this bi-directional model? So it's not just there's the way that you move changes maybe the way that your cognition works, but also mindset effects or belief effects, or like what we have like around placebo effects, like also the way that you'll think will also affect the body.
100%, yes. And the reason those things exist is not because there's two things and they're connected. It's just there's one thing. And that's a philosophical view that I think is largely being confirmed with neuroscience. So, right, in philosophy of mind, you're a dualist. You could be
Again, Descartes, like he's like, there's two substances. There's the mind, and then there's, what would you call this? Okay, if it's really one thing with maybe two modalities that are playing off each other like this, what would you call that philosophically or in the world of ideas? Like, what's that? Is it some form of monism, I guess?
Yeah, that's a good call. I think there's a word. There's a couple of titles. I think emergent physicalism. So it's a
Mm,
physicalism. Yeah,
it's a nice one. Sounds nice and complex and kind of scientific sounds.
I think emergent physicalism is the view, and I haven't studied this in a while, but it's a physicalist view, but that mental states, mind, right, is explainable through physical things, neurons, brain firings, brain cells, but are not reducible to neurons. You can't reduce an emotion to neurons firing. But you can explain it through that, and now through this idea of dynamical coupling. I think the brain is a dynamical system, and we can get into that. But so that's not just an information processing thing that produces consciousness, right? It's this dynamical embodied system that interacts with the environment, and out of that coupling, that interaction emerges and is emergent property of, like, consciousness, let's say,
I,
or sensation, let's say. Like, that comes from complex adaptive systems too.
I think this is a really it's a really big idea. I think that really kind of transcends a lot of our models, like the regular models that people have when they think of the brain, when they think of thinking. And I think as I was grappling with your work and with the different ideas involved in it, I'm like, this is like perhaps in the words of Kuhn, like this is perhaps a new paradigm that's emerging. It's maybe like
Mm-hmm.
it's bigger than just
Yeah.
like just another idea. It's really really big. And I'm like, okay, so a lot of things that you just said now, you said, the thinking is not just in the brain, it's an embodied process.
Fred, you hit the nail on the head. It's thinking and consciousness and cognition. It's clear that that's not just in the head. It's not just in the head, right? It can't be reducible to neurons firing. I think that's pretty clear. And I think there's plenty of experiments and things that are data that are coming out now that sort of really illustrate that and demonstrate that. One study that came out recently showed that, let's see if I can describe it right. But so, like, gestures, right? So I'll give you two experiments. Gestures are a really good example, I think, of embodied cognition. So the meaning of words, right? They trained people to translate foreign words, and in one group, and then in another group they did the same thing, but they were using gestures and body movements to, like, associate with those words. Of course, the people in the second group remembered the translation of those words better. But not only that, when they put those people in brain scanners and they asked them, and you're not moving in a brain scanner, you're just like, you're stationary. When they asked those people in brain scanners to translate the words that they had learned with the movements, parts of their brain that were lighting up that were not involved in the memory, but involved in movement, body movement and gestures. And then in another experiment, they actually asked people to think about the sizes of objects and compare the sizes of objects with brain scanners on. Like, so cup or broom, and then objects that were not manipulable but really huge, like lamppost or building. And in one experiment, they had them restrain their hand movements but able to look at their hands. And then in the other one, they were able to freely not move their hand. They were able to freely move their hands, but they were still told to just keep them down. But they were able to move them if they wanted to. And so the bottom line is they found that when you constrain people's hand movements, they have difficulty understanding the semantic meaning, the semantic content of the sizes of objects. When you restrict people's body movements, they have trouble not only, like, identifying the sizes of objects, but understanding the meaning of the sizes of objects when they think about them.
Wow. I'm just curious, is your proud Italian heritage part of the reason why you're so passionate about all this research about gestures and cognition?
Possibly there's some transgenerational epigenetic component to.
It's Mannino, not Mannino, okay? Don't Americanize my name.
Possibly, yes.
That's really interesting.
Yeah.